This lesson is about special triangles. The first triangle we want to look at is a 45, 45, 90 triangle as shown here. The two short sides are called legs, the longest side is called the hypotenuse, and here's some facts about a 45, 45, 90 triangle. First, the legs are equal. That shouldn't be a surprise. The hypotenuse to leg ratio is radical 2 to 1. We'll look more at that later. Here's our first example. Well, looking at the angles of the triangle, the first thing we can deduce here is that since this angle is 45 degrees, so must the other one be. That makes the angles add up to 180 as they always do in a triangle. So now we know we have a 45, 45, 90 triangle, and our goal is to find out the values of x and y. Well, we can use the hypotenuse leg ratio of radical 2 to 1. Now, since we know the hypotenuse and we want one of the legs, and since the leg is shorter, we would have to divide by radical 2, and that gives us the leg. And since the legs are equal, the other one must be the same. Here's another example. In this case, we're not told that we have a 45, 45, 90 triangle, but since the legs are equal, they're both 5, then it must be the case that we have a 45, 45, 90 triangle, and therefore theta is 45. Now, in terms of solving for r, we can again use the radical 2 to 1 ratio. Only this time we know the leg and we want to know the hypotenuse. The hypotenuse is longer than the leg, so we're going to have to multiply the leg by radical 2. So there's the value of r, 5 radical 2. Here's another example. Again, because we have a 45 degree angle there, the other one must be 45, therefore we have a 45, 45, 90 triangle. And since we want to know the value of x and y, we can again exploit this radical 2 to 1 ratio. Now this time we know the hypotenuse, and we want to know one of the legs, which is shorter, and therefore we would divide by radical 2. This of course simplifies to 13, and since the legs are equal, the other length must be 13 as well. Here's yet another example. Now they don't give us any angles here, but again, since the legs are equal, we can assume it's a 45, 45, 90 triangle, and since it is, theta is 45, and once again we can use this radical 2 to 1 ratio between the hypotenuse and leg. Now since the leg is known and the hypotenuse is longer, I'd have to multiply it by radical 2 to get the value of r. Of course, this multiplies out to be radical 12, and technically you could leave that, but it's kind of sloppy math, so you're better off factoring 12 and simplifying your radical, as we always do. Let's now focus our attention on a different special triangle, the 30, 60, 90 triangle. Here's a 30, 60, 90 triangle. In a 30, 60, 90 triangle, none of the sides are equal, as they were in the previous. But we do have a short leg and a long leg, both of which are shorter than the hypotenuse. Here's some basic facts about a 30, 60, 90 triangle. The short leg is opposite the 30 degree angle. The ratio of legs is radical 3 to 1. And the hypotenuse to short leg ratio is 2 to 1. Let's see how we can use these facts to actually solve some problems. Here's our first example. Now they don't tell us we have a 30, 60, 90 triangle, but they do give us the 60 and the 90. Since the angles of the triangle have to add up to 180, then of course this would be 30. Now let's use the fact that since we have a 30, 60, 90 triangle, the hypotenuse to short leg ratio has to be 2 to 1. Well, we know the hypotenuse is longer, obviously, and since that's 22 and they're in a 2 to 1 ratio, then x must be half of that. Therefore, x, the shorter leg, is 11. But now we need to find y. Well, let's exploit the fact that the ratio of legs is radical 3 to 1. That means that y, which is obviously longer than x, has to be x times radical 3, or 11 radical 3 in this case. Here's another example. Now here they don't give us any angles at all, so we don't have any evidence that we have a 30, 60, 90 triangle. We clearly don't have a 45, 45, 90 triangle because the legs are not equal. But we would know we had a 30, 60, 90 triangle if we could prove that the ratio of legs is radical 3 to 1. But looking at the legs, that's obviously the case. Therefore, we can assume that we have a 30, 60, 90 triangle. And since the short leg is always opposite the 30, and 4 is the short leg, then theta must be 30. Now, in order to find r, we can use the fact that the hypotenuse to short leg ratio is 2 to 1. Or more simply put, the hypotenuse is twice as long as the short leg. Short leg's 4, hypotenuse is 8. Here's another example. Knowing that one of the angles is 30 means the other one must be 60. Thus we have a 30, 60, 90 triangle and all the facts above apply. So let's see. If we look at the 2 to 1 ratio between the hypotenuse and the short leg, we'll be able to find y, since y is the shorter leg. The 2 to 1 ratio essentially implies that y is half of the hypotenuse, and therefore must be radical 30 over 2. Now let's find x. Let's use the fact that the ratio of legs is radical 3 to 1. Well, x is longer than y, and therefore x must be y times radical 3. Simplifying this gives us a more acceptable answer to the problem. And here's our last example. They don't give us any angles, so we don't have any evidence that we necessarily have a 30, 60, 90 triangle. But if we could prove that the ratio of legs is radical 3 to 1, then we would know we had a 30, 60, 90 triangle. Well, that does turn out to be the case, but to prove that, we need to take the short leg, multiply it by radical 3, and prove that that's equal to the longer leg. Here's the short leg times radical 3, and a little basic algebra does indeed prove that the short leg times radical 3 is the longer leg. And therefore, since they're in a ratio of radical 3 to 1, we must have a 30, 60, 90 triangle. Furthermore, the short leg is always opposite the 30. But 5 radical 3 is the short leg, and not only because it appears shorter, but if you worked out 5 radical 3, you would get about 8 or 9, clearly shorter than 15. That tells me the 30 has to be here, and therefore theta is 60. And finally, to solve for r, we'll use the 2 to 1 ratio again between the hypotenuse and the short leg. Since we know the short leg, and we want the hypotenuse being longer, we're going to have to multiply. Multiplying the short leg by 2 gives us the hypotenuse. And that completes the lesson.